Hey guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the introduction to transition elements. And this, of course, is going to be combining with the previous videos we have done on comparative study of S and B block elements. Now, before I proceed, I kindly like to request our members to subscribe. Engage us in the comment section and also ring that notification bell to be getting updates on our various discussions in math and sciences. Now, in this particular discussion, we're going to look at various characteristics, and these are going to assist us to distinguish between the S, P, D, and F block elements of the periodic table. In our previous videos, we have dealt with in details the concept of the S block elements, which constituted basically the alkali metals, the alkaline earth metals, and this particular group of elements ranging from, of course, group 3 or 13 to 18 given in that particular order. And there were various names which we, of course, gave especially to the second last two columns which we have given in terms of this one's coded in yellow, basically referred to as halogens, which means they are salt producers. The last ones are inert elements, or referred to as the group 8 elements, and these are going to be a group of elements which have, of course, obtained the octet of electrons in their specific configuration. Therefore, as I mentioned, they are going to exhibit a limited number of course, reactions, except for krypton and xenon, which we have said will form some of the compounds. Now, in this particular case, we had, apart from the S and P block elements, we had basically divided this periodic table into a number of divisions, which constituted this middle section, which is going to be given in this particular block. Now, this one constituted the transition elements, whose integral parts is going to constitute this lanthanide and actinide series from this specific atomic number. But of course, they have been separated in this particular section at the lower part. But basically, this is going to be an integral part of the D block elements, and therefore these were divided as the outer transition metals and the inner transition metals in this specific case. Now, having mentioned that these specific elements which are going to be falling under the category of transition elements are metals, therefore we are going to expect that they are going to display various characteristics of metals which we are listed in our introductory part to the concept of S and P block elements. Now, I'd like to request our members to be checking our description boxes for various links of these specific videos, and also be checking or engage us in the comment section so that we can be having a reference of those specific discussion. In this particular case, we're going to look at the transition elements in terms of different families, whereby we're going to have or different groups, whereby we're going to have the first element representing particularly a reference for those specific groups. So the first one is going to be the scandium group, which is going to consist of scandium, yttrium, and lanthanum and actinium given in that specific order. So basically, I'm just going to refer to this one as the scandium group. And then we shall have the titanium group, the vanadium group, chromium group, manganese group, iron group, cobalt group, nickel group, copper group, and zinc group, which is going to form our final part of this specific transition element. Now, one of the unique characteristics which we're going to see with the transition element is basically that these are going to be elements that are going to be having the D subshell, which is next to the last being occupied, or the last electrons occupying this specific D subshell, which is going to be next to the last shell, as we're going to see in some of our illustrations. And then we shall have this specific section which I refer to as the inner transition elements. And these are going to be the lanthanide and actinide series, which basically is going to form a second category, whose last electrons are going to enter the F subshell in the N-2 shell, just as we had mentioned in our introductory part. So this basically is going to be how we are going to look at these specific elements. Now, in my next discussion, I'm going to look at basic characteristics and some of the definitions which we are going to come across, and those are going to assist us in trying to analyze this various range of transition elements across the periodic table. So I mentioned basically that these specific transition elements are going to constitute metals, and as I've said, these are going to be constituting of the inner inner transition elements, and then we shall have the outer transition elements, which are of course mentioned in our last discussion. So this is going to be arranged from these particular elements. So we had stated that these are going to be, especially for the inner transition elements, the inner transition elements, these are going to constitute the lanthanide and actinide series, which are going to be basically referred to as the F block elements. So they said that basically these F block elements are going to be an integral part of the D block elements, but basically we're going to give them as F block elements for due to the reason which are mentioned of their outermost electrons occupying the F subshell given in that specific order. Now in this case, for the outer transition elements, they said that these basically are going to be different groups which are mentioned, starting from scandium to zinc. So for the scandium group and the zinc group in that specific order, for the various groups ranging from group number 3 to 12, this is going to form a range of transition elements which we are going to study in these two specific blocks for the inner and outer transition elements. And in this study we are going to look at various characteristics, especially the periodic trend which looked at various discussion on the concept of the S and B block elements. And now among these characteristics I mentioned the concept of an atomic size, or the atomic and ionic sizes. So we're going to look at how the atomic and ionic sizes are going to vary across the periodic table. And I said, of course, we shall look at the concept of ionization energy. And I've mentioned the concept of, apart from ionization energy, the concept of electronegativity. And of course, in this specific concepts, as we are going to see, we mentioned the concept of these particular energy levels, which are going to be affecting the various periodic trends which you have mentioned and listed on the board. And of course, these are going to constitute the various trends which we are going to be particularly concerned with in the periodic table. Now, the concept of the atomic and ionic sizes are going to be, or basically these are the distance from the nucleus to the outermost occupied energy level in terms of an ionic form or atomic form of the various elements across the periodic order, across or down the various across the periods and down the various groups of the periodic table. And the ionization energy is basically the amount of energy needed to remove or lose an electron from the outermost energy level. And that is going to form part of our discussion, and we're going to witness various trends of these particular families of the transition elements. The concept of electronegativity basically is the ability of this specific, or the tendency of an atom to attract electrons. And this is going to exclude the noble gas or the noble elements which are listed, of course, in my last column of the periodic table. Now, in this particular case, these are some of the trends that we're going to look at, especially for transition elements, and they're going to assist us in trying to predict various trends, of course, which we are going to use, and particularly try to see a contrast between these ones and the S and B block elements from our last discussion. Now, particularly, I mentioned that these transition elements are going to be classified according to the, of course, the occupation of the orbitals which the last electrons are going to be occupying, and therefore we are going to see that these are going to be making this transition element exhibit various characteristics. Now I can just perhaps have this specific concept of a summary of what I've mentioned, in particular a statement form which is going to assist us comprehend these particular characteristics. But I mentioned basically that these transition elements are going to have characteristics of metals. So it is essential for us to remind ourselves of the various characteristics which we are going to witness for metallic character. Now I've mentioned this case for the concept of being malleable, ductile, good conductors of heat and electricity, high density, high melting and boiling points, and of course they are shine and hard in some of the metals which we are going to be coming across. Now, in our next discussion, we're going to look at the various, of course, groups which I've mentioned. And this is going to assist us in trying to, of course, appreciate the various characteristics which we're going to witness or come across for the particular families or groups which I've mentioned from my previous illustration of the periodic table. Now, this is going to be shedding more light for us in various trends of the S and perhaps P block elements, and in contrast with the D and F block elements of the periodic table. So catch us in our next video and check our description boxes for various links of other similar videos. And those are going to assist us in understanding the transition elements in deeper detail. So that is it for now, guys. By God bless you. Catch us in our next video.